Hi everybody. I'll give a little spiel here before we have a minute left. My name is Dan. I work at a little company called Authz. We do some stuff that's fun. Mostly what I get to do is work on open source and talk about open source, and I get to do a lot of education stuff and like write documentation. And it's a pretty cool opportunity to be able to work on open source professionally full-time. And I just want to say thank you to my employer, actually, for taking a chance on that. So awesome. Okay, cool. So here's what I want to talk about today. I want to talk about authorization as a developer workflow, specifically in the context of cloud native development, which is a space I work in a lot right now. I work with a lot of CNCF projects, working with a lot of like OpenID projects and stuff like this. But the stuff I'm going to be talking about today is broadly applicable even if you're not in a cloud-based environment, right? Because at the end of the day, everything that runs in the cloud can run on a computer on-prem as well, right? I'm not going to be talking about anything that's specific to vendors. I'm not going to be talking about anything specific to like AWS or anything like that. Everything I'm talking about today is open source, open standards. So I'm pretty militant, so that should flow through. All right. So I said, my name's Dan. I work at a company called Authz. Before this, and I'm just to give you context to understand my own biases, which is important. Okay, I have been able to work at a lot of neat places in the course of my career, like Ubisoft and Mozilla, back when Firefox was still relevant, and Datadog, back when it was still relevant, and I've gotten to dabble in a lot of things over the course of my career, a lot of infrastructure. I started off as a sysadmin, if anybody remembers what that term means, back in the day. I've done a lot of development, and now I get to work actually a lot in the security space. I'm really into operational security in particular, but I do dabble in AppSec as well. I say these things only, again, to give you context about the rest of this talk, so you can understand, again, where my biases are. One of the things that I've learned over the course of my career is specifically related to authorization. That's what inspired the talk here today. And authorization, which of course is related to authentication, is often treated as a security problem, and just a security problem, and it's not. It's a developer problem as well. And it's a developer experience problem, and something I feel acutely, basically every day, and that's what I want to talk about. So I want to start with something called the authorization paradox. I did not come up with this term. This is a term that exists. And basically it's that like every application there is that you can log into, period, has authorization built into it in some way, right? It's unavoidable, it's critical path. Every request has authorization tied to it. But it often remains a complete afterthought when we think about designing our software, we think about writing our own software, right? A lot of security stuff is an afterthought that gets tacked on later, kind of like writing docs, but authorization is stuck in a really weird place. We've solved a lot of these similar challenges in the past as an industry. Like think about how deployment evolved from bash scripts to configuration management and CI/CD pipelines and stuff like this. Think about how observability went from mass SSHing into machines and prepping through logs to single panes of glass and open telemetry and stuff like this, right? Works really well. But authorizations remain stuck basically in this like weird spot. And this weird spot as a developer, for me, it tends to create friction instead of flow. And when you have friction as a developer, what happens is you have workarounds. And those workarounds generally lead to nasty outcomes, right? Unmaintainable code, security problems, things like this, right? And this disconnection is kind of like the central thesis today. So we have to think about, and here I have on the slide how cloud native development has evolved. I literally just did this talk, a version of this talk at KubeCon, so sorry, my slides are a bit more geared towards that right now. But to use more examples, right? Networking, right, went from, basically telnetting into Cisco routers and updating configurations on the fly. And now we have service messages and CNI. Storage moved from a bunch of hard drives racked somewhere, which is fine, by the way. I still have a bunch of hard drives racked somewhere. No shame, right? But now we have persistent management, volume management. We've got deployment. We've got GitOps pipelines. So, like as an industry, we've done some really good work. And authorization is moving in this direction, but it's not quite there yet. So it's moving from the scattered implementations to more coherent primitives that we can implement as developers, which we're going to talk about today. But why is there this lag, right? So I can tell you that there's this lag, and maybe you believe me because you think I'm credible, or I can give you some proof, right? But why does this lag exist? The first problem is that authorization tends to be fairly deeply coupled with application logic. We've been able to externalize a lot of things and standardize a lot of things in our industry, but authorization is pretty tightly coupled, generally speaking, with application logic. It makes standardization difficult as a result. Requirements for authorization are often domain specific, so like something that works in finance might not be the same thing that works in healthcare, might not be the same thing that works in Uber for dogs, might not be the same thing that works in your dating app, right? Standardization is difficult because it's so tightly tied into it. Also, things are just a lot more complex than they used to be, right? Back in the day, I could throw 3.5 millimeter, 3.5 inch, sorry. I grew up in a place where they use the imperial system. Anyway, 3.5 floppies into a machine and like install Linux and be like, that's our computer now. And that one computer ran the whole business, right? We don't do that anymore. So think of like Google Drive sharing permissions or like Slack rules and stuff, right? They're actually like really, really complex and ornery underneath. Fourth, also consider that every framework and every language that you have ever used over the course of your entire career has reinvented authorization and has reinvented it differently, right? Which means there's no one way to talk about it, really, right? Spoiler alert, there is, but traditionally there hasn't been, and that's been making it difficult to even have coherent conversations around authorization in a way that we can have coherent conversations around other types of development and infrastructural primitives. So authorization is basically this like awkward bit whale, black sheep, right? That nobody, like everyone knows it's there, but no one wants to talk about it, right? It sucks. But there's a cost involved with this, right? Like it's not just that the experience sucks; it's that this actually costs money. Whoops. We have developers constantly context switching between features and permissions. We have business logic; it's all tangled together. With these authorization checks, you get security issues when permissions are inconsistently applied across the code base. This slows down developer velocity, which sucks, because you have like, you want to make a simple permission change, but your permissions are stuck in some sort of UI widget somewhere, and then when somebody updates the UI widget, it like makes 14 million private posts public. Facebook 2016, definitely read that paper, it's super interesting. Very embarrassing for Facebook at the time. Onboarding becomes an issue. If you've ever had to enter into a new code base as a developer, you already know that it's going to be hard, right? New code bases, other people's code is hell, right? And especially when you have something that's tangled mess like authorization stuff, spending weeks or months trying to figure out what it's doing instead of concentrating on doing your job costs your business money, right? That sucks. So it's not just a security problem, it's not just a developer experience problem, it's like kind of an everything problem, right? But if we change our way of thinking on it, and we allow authorization to become a creative tool instead of a constraint, then we can allow developer experience to sort of flow naturally without being immersed in problem solving, without fighting tools. And that's what we want to get to as an industry, right? So authorization today breaks that flow, but it doesn't have to. The idea of thinking about authorization as being declarative instead of imperative, right? As being what can we enable as opposed to what can't the user do, right? Finding ways to make it live in well-defined places instead of scattered throughout the code, right? Coming up with these abstractions that we can use across the industry to start talking about it, and as developers, how we can interact with authorization and create better security outcomes and have a better experience doing it. So we want to treat authorization as a foundational architectural concern. So, and I'll just kind of gloss over this, but it's sort of a workflow-first approach that we see in some of the other tooling that we have available to us now as modern technologists. The idea of separating out business logic from database concerns, giving authorization sort of a first-class architectural mindset, right? Service contracts, API contracts, testing strategies, deployment lifecycles, all the things that we normally think we should have in modern software, but applied to this is the idea. And if you're looking for a really good paper on a company that did this a long time ago, like this is already a decade now, is Netflix. Netflix moved to a service-based decoupled authorization model 10 years ago, and really set the stage for a lot of the discussion that we're having on the topic now. So definitely go read their papers on the topic. And again, this idea of moving from constraint to feature. So traditionally the question, which is that imperative question, what can't the user do? It's a negative framing, and that negative framing creates necessarily negative codes, right? You're negating functionality. That's the wrong way of thinking about it, right? Instead, what can we think about, what can we enable? And when you start talking about enabling functionality, that sounds an awful lot like features, right? And all of a sudden, you as a developer have to go talk to product. Oh, scary, uh-oh, product, they have project managers, they have sprint boards, milestones. Okay, yeah, definitely do that, because when we move from authorization as a constraint to authorization as a product feature, as a discussion, really, really interesting things happen. Slack is a really, really good example of that. Say what you will about Slack, and have a lot of things to say about Slack. Not all of them are good. But they transitioned really well from being this way that people talk to each other using a computer to being a thing businesses use to actually make their businesses go, for better or for worse. How did they do that? A lot of it was around this idea of authorization driving product features. So let's talk about some principles that you can apply, right? So our first principle is domain-driven authorization. This means modeling permissions around business domains instead of technical constructs. Most frameworks that exist today are really built by nerds for nerds by me. Like if I'm sitting down and be like, I don't know, admin, user, editor, reviewer, some crud, right? Maybe I'm thinking, I got my like desperate little POSIX brain and I want to do rewrites, you know, and execute on stuff, right? That's fine, that works, but it doesn't reflect how businesses actually function, right? So this, when we talk about product language, and we start to abandon CRUD operations on database tables, right? It creates a shared vocabulary that we can use as developers between product and development and security and operations and everyone. And that's actually really powerful. So when you think about maybe a document management system or content management system, while update :document.true might be the technical construct, really what that means is editor. So start thinking about it that way, right? This approach aligns with how users think about your application, and this is actually super clutch for developer experience in creating better code. The second principle is using declarative policies instead of imperative checks, which I alluded to a little earlier. So traditional approaches, like if user dot has permission, then whatever, right? That's fine, but it becomes hard to maintain because it leads to like these really tangled rat's nests of if-else's and exceptions to exceptions to exceptions to exceptions, and like case statements nested 9 layers deep, right? And that sucks. So the idea is to make this declarative instead. And this was one of the big revolutions of modern configuration management, was to declare state as opposed to try to enforce it, which is really, really interesting. So the idea is to become human readable, or as close to possible as human readable as stuff can be, and then these artifacts can be version controlled, they be reviewed independently. The policies, this idea of policies driving authorization logic, should clearly express business rules and should actually in some cases be externalized entirely from your application so that they don't get nested into your code. So they can be thought about and reasoned about independently of the code that you're actually writing. And this approach is really nice because it scales really well, right? Like your policies and your business logic can grow independently of your code base. Your code base can change independently of your authorization logic. And that's a really good thing when you get to certain levels of complexity. Our third principle is external decision points to decouple authorization from the application entirely. So instead of just removing the logic, let's actually remove the functionality entirely, right? Like let's not even do authorization functionality inside of your code directly, which is a really, really wild idea. And it took me quite a while to become comfortable with this, to be perfectly honest. So rather than embedding checks all over your code, your application just makes a query, right? If it's a microservice environment, it's going to make an HTTP call, like a gRPC call. It could even be local, right? Just be like piping something. Don't worry about it, right? The idea is that in the same way that we dedicate services for all sorts of other things, maybe authorization too, right? The application just asks, can the user do this? Yes or no? And then something happens, decision gets made, and then it goes yes or no, and then your application keeps going, right? This ensures consistent enforcement of authorization across all of your services. You don't have to replicate authorization code in multiple places, which is really, really nice. It allows authorization logic to scale independently. It prevents bottlenecks, the application grows. And the really cool part about this is that authorization becomes testable in isolation. So before, where you have to run all of your authorization unit tests as part of your testing suite for your code, now you can just run that separately, which is really, really good for submitting your code when you check it in and then you have to sit around for like 45 minutes waiting for it. Well, this is a way to reduce some of that time, right? If you didn't make authorization changes to the authorization code, because you know you did it, because it's literally somewhere else, you don't have to recheck it, right? Which is really, really nice. Developers, we still need to understand the model, obviously, but we can focus on the core business logic of the code of our application as opposed to having to deal with this, right? Fourth principle is making authorization context aware. And this is something that's a bit more arcane if you've never worked with authorization before, so I'll spend a moment here. The idea is moving beyond simple role-based systems by considering attributes like, I don't know, like time, location, 10 minutes, oh God. Are you kidding me right now? Okay, adapt situation. So a healthcare system, for example, might be like, yeah, you can access this, but only during like business hours. So the idea is to add context to it, right? Instead of just being like, a nurse can access this, or doctor can access that, be like, nurse can access this under this condition if they're badged in this way at this facility during these office hours when they happen to be on shift, so on and so forth, which is impossible to model using roles. You literally can't do it, right? Unless you have like thousands of roles, which sucks. So context awareness enables this idea of fine-grained control. And usually when we talk about it in the world of authorization, we talk about ABAC, or attribute-based access control, which is different from RBAC. ABAC is great, but you need more advanced tooling to make it go. And a lot of frameworks that we use today, Django or whatever, simply don't support it at all. And that's a really good segue into the next part of this, which is, let's look at some of the tools that are out there, right? Recent years have seen like a pretty rich ecosystem of tooling sort of emerge in the CNCF and elsewhere. And some of these tools take different approaches, different policy enforcement, relationship-based permissions. Some are Zanzibar, some are OPA, like it's all over the place. Some prioritize developer experience, some prioritize scalability. They all do different things. But the idea is that they are out there, and they are standardizing, and they are incubated, in some cases graduated projects, which is really, really important. So let's explore a couple of them. First one I mentioned is OPA, or OPA. It's a graduated CNCF project. And again, you can have opinions on the CNCF. We're not here to debate that statement I'm making, okay? It's pretty widely adopted for what it is across a lot of different industries. It's a general purpose policy engine. So it's not just for applications, it's not just for infrastructure, it's kind of just supposed to be an authorization engine. It uses Rego as a policy language underneath REGO. It has advantages and disadvantages. One of the big advantages of OPA and Rego is that it is general purpose, so you can sort of cram it in sideways everywhere. One of the big disadvantages to OPA and Rego is that it's general purpose, so it tends to get crammed in sideways everywhere. It doesn't do anything particularly well, and the learning curve is pretty steep. But if you're willing to take that on as a challenge, it will do everything you need it to. Right? So pluses and minuses. There's also OpenFGA, another CNCF project, although this is in Sandbox. This one is built on top of Zanzibar, which was a landmark rule paper from their Beyond Corp thought experiment from a couple of years ago. This is the system that, Zanzibar is the system that drives Google's global permission system, which is all REBAC, R-E-B-A-C, or relationship-based access control. So OpenFGA is all about performance at global scales, and it's all about the relationships of principles to each other. So if you're thinking to yourself, wow, like, this sounds great, I really want to implement this, this is the thing I want to use, maybe it is if your problem set is the same problem set as Google. If your problem set is the same problem set as Meta, that this is what you need. There's like literally no other solutions out there. Most people don't need this. Most people, this is actually overkill, but if it's what you need, it's the only possible way to do it. Fair enough? Right. I also want to point out the OpenID Foundation, which is not CNCF, right? OpenID Foundation, which you may know from Authz or OpenID specifications, OpenID Connect, right? If you've ever worked with that before. They have another working group called Authz. Authz focuses on interoperability, so creating these sort of common interfaces across different implementations. It's not about specific solutions. It's about a commonality, about a common language that different companies can use to work together. It's a working group. They're making progress. Definitely go check their website out. They got a lot of really interesting papers. And then ultimately the work that they're doing is going to define authorization as a common language over the next decade. So if you want to get the jump on it, now's the time, right? I also want to point out the company where I happen to work very, very briefly. It's not a sales pitch, but we also do make an authorization solution, which is why I talk about this stuff a lot. We take a different approach. We're part of Authz, so we're standard interop, which is really, really great. But we have a different approach with sort of YAML-based policy language. It's super human readable. And we want to be really developer forward. So this idea of like local tooling, local testing frameworks, local deployables, and stuff like this. We have opinions on how authorization is supposed to work. So it doesn't necessarily work for everyone, but it works for us. Anyways, I'm not trying to sell it. If you want to know more, let me know after. Okay. Basically, there's no one-size-fits-all solution. That's the biggest thing here, right? You have to really analyze what your problem set is. You know, if you need broad policy enforcement that goes kind of beyond authorization, you know, OPA might be what you want. If you have complex relationship-based permission problems at, you know, international scales, then OpenFGA might be it. If you're really interested in cloud-native, super, super tight, developer-centric workflows, check out Servos. It's also okay to use multiple tools, right? I've seen people in the wild using like OPA for one thing and like, you know, OpenFGA for another, for example, so that's really okay too. I do have a whole section here on basically like patterns for implementing this. And this is really adapted from like a master class that I sometimes do on this subject. So there's way too much content to go into super in depth here in a very, very short amount of time that we have allotted to us. But I do want to point out a couple of things. This idea of architectural patterns, developer patterns, and testing patterns. So we have 3 different ways of thinking about this. Thanks, man. 5 minutes. And I want to talk about authorization as a service. I already alluded to this earlier. This idea of completely removing authorization and putting it into a dedicated service, right? And it's a microservice and it runs and it does the job. All this stuff we talked about earlier, OpenFGA and OPA and Servos, some of the other solutions, anything that's based on Zanzibar, this is how they work. They all work like this. This is where modern authorization is. So this is not theoretical. This is a today thing, right? We already talked about some of the reasons why this works really well. It especially works really well in microservice architectures where you have centralized governance, so on and so forth. But if you've ever worked in a microservice environment, especially a microservice environment where you're making network calls outside of your rack, which happens all the time, you run into things like network latency, bottlenecks, split brain, all those sort of things that make the internet super, super fun. And so I also want to mention sidecar deployment as a model. If you happen to be using Kubernetes, right, but this also applies to other types of models in principle, which is the idea of taking that service, whatever service is making those authorization checks, and putting it as close to your application as possible. So you want to avoid a situation where you've got your authorization service sitting off in some data center somewhere, and then you've got your applications sitting off on the other side of the world somewhere making checks to it. That sucks, don't do that. That's a mistake, right? Instead, you want to have tiny little authorization deployables scattered all over the place, and make them as close to your application as possible in order to prevent bottlenecking and so on and so forth. But then you have to manage that, and I actually have like a whole spiel on how to manage that if you want to learn more afterwards. I'd be happy to tell you how to manage that. I also want to talk about multi-layer authorization. As I mentioned earlier, I'm really into OPSEC. And a big principle in OPSEC is defense in depth. This idea that you need to have like trust but verify everywhere, right? Deny by default, check always. So someone logs in, okay, they've got a token. Don't trust that token. Right, at some point check it again. Someone logs in and you're like, well, they were able to edit that file 5 minutes ago. Are they still able to edit that file now? No, check again. Right, constant checks at every layer. This idea of defense in depth. And again, here, there's like a whole like section of the workshop that we do on this. But an important point is that this idea of this defense in depth, right? Multi-layer authorization. This idea of policy-driven design. Everybody in this room, I trust you. I know that you're all super experienced developers, and everyone in this room practices TDD, or test-driven development, right? Where you write your tests and you write your documentation, you sit down with your product people, and you like map out those features, and then you really think hard about it for like 3 or 4 days, and you sit down in front of the IDE and write pristine Mona Lisa level code, right? That you don't even need, like, whatever, check it in, but we don't even bother running the test suite, it's perfect. Policy-driven development or policy-driven design is the same thing, but for authorization. Start with first principles, start with the feature, start with the user need, start with the product requirement, and then work backwards from there to design your policies. And then work backwards from there to design the code that actually uses those policies, right? It's a really weird way of thinking about this if you've never done it before, to be perfectly honest, but I find it really powerful. I'll also talk about request context enrichment, or RCE. Again, these are terms. This is all about basically augmenting and enriching responses. So it's not just can user do X, or should user be allowed to do X. You can actually use this as a mechanism for discovery. Really, really interesting way that this gets implemented is if you need to make a database query, for example, and you know the response you're going to get back has like 1 million rows in it. That's an intense database query. And then you have to filter those 1 million rows and figure out what the user can or can't actually have access to. That sucks, it's a heavyweight transaction. Instead, you can make an authorization check to see what sorts of things the user should have access to. And then in principle, your authorization provider, whatever it is, might be able to hand you back like a lens, like maybe it's a Prisma or something like that, right? And then you can use that lens as a partial query to build out the query and get a lighter weight response back. I have a ton of examples of this for like front-end development and whatnot too, which are really, really interesting. How to like structure queries in mobile or low bandwidth environments, so you're actually only getting the JavaScript and the artifacts that you need instead of sending it all down the pipe. Happy to talk about that afterwards as well. Super, super cool stuff. You got to be able to test everything. Test everything, test everything, test everything. If your authorization framework does not have a sane way of testing, this is like, you need to fix this, right? Test fixtures are part of that same authorization framework, and again, I know I'm going super fast through this right now, but super, super important. Develop test scenarios, not just unit tests. Like actually go end to end. What does the user workflow look like, right? Find those edge cases, and then write your policies to deal with those edge cases. Really last thing I want to mention is around this idea of practical workflow integration. In the same way that we treat code today as something that is almost inseparable from our IDE, something is also inseparable from how we think about deployment models and like what's getting checked in and whatnot. Think about authorization the same way, right? Time's up. Awesome. Security by design, empowered by developers. Thank you very much. Appreciate it.